So today we're doing a physics problem. So the problem is a particle moves according to a law of motion, s equals t cubed minus 12t squared plus 36t, for t is greater or equal to 0, where t is measured in seconds and s is in meters. So part A is find the velocity at time t. So the velocity at t is the same as the s prime at t. So we just use a normal power rule to find that, which equals 3t squared minus 24t plus 36 meters per second. Part B, find the velocity after 3 seconds. So the velocity after 3 seconds just means sub the 3 into this equation up here, which we found for the velocity. And that gives you negative 9 meters per second. So C, when is the particle at rest? So a particle is at rest when the velocity equals 0, that is the gradient equals 0. So therefore in this case we use our velocity formula from up here, so 3t squared minus 24t plus 36 equals 0. And then just use factorization rules and we end up with t equals 2 or t equals 6. So therefore the particle is at rest when t equals 2 and when t equals 6. In hindsight, I should have actually subbed these in back into the original equation to find the y values of those points as well, so I had a full point. And that would have just been s of t back in this equation up here. And part D, when is the particle moving forward? So the particle is moving forward when the velocity is positive, when the velocity is greater than 0. So for this, I would just graph the velocity on the calculator, and this is a rough sketch of the velocity the calculator gave me. And then I would just use second calc to find the zeros. And using that, this 0 was 2, and this one was 6. So therefore it's moving forward at t is less than 2, and t is greater than 6, because those are the two areas here and here where it is positive. So part E, find the total distance travelled during the first 8 seconds. So, because the particle changes direction, because as we know it's moving forward here, but it's negative here, so that means it's moving backwards, and positive here again, so it's moving forwards again, we have to do it in 3 separate equations, and we have to take the absolute value of each, because we want the distance, not the displacement. So that would be the s of 2 minus s of 0, the absolute value of s of 2 minus s of 0, plus the absolute value of s of 6 minus s of 2, which is the part in here, and plus the absolute value of s of 8 minus s of 6, which is going back off that way. So that equals 32 plus 32 plus 32 equals 96 meters. Part F, find the acceleration at time t and after 3 seconds. So the acceleration is just the v prime of t, and using the power rules, that's just 6t minus 24, and after 3 seconds, just sub that in, which gives you negative 6. And part G, so graph the velocity function for 0 is less than or equal to t is less than or equal to 8. So I just graphed it in general, I didn't stop at 0 or at 8. So I just used the calculator to do this, and then I used second calc to find the minimum value down here, which is 4, negative 12, and to find the two zeros, 2 and 6. So when is the particle speeding up or slowing down? So we know a particle is speeding up when the velocity is greater than 0 and the velocity is increasing, or when the velocity is less than 0 and the velocity is decreasing. So therefore, in this case, it is speeding up at t is greater than 6, and 2 is less than t is less than 4, and slowing down at t is less than 2, and 4 is less than t is less than 6. So we see that here, because in this section here, while it's positive, it's decreasing, so we know it's slowing down. In this section, it's negative and decreasing, which means it's speeding up. And as you can see, those two correlate. This one, 2 is less than t is less than 4, and t is less than 2. And then here, it is negative, but it's increasing, which means it's slowing down, and that corresponds to this one right here. And in this section, it's positive and increasing, so it's speeding up. T is greater than 6. So that's it.